Good afternoon, everyone, and welcome to today's webinar sponsored and presented by MAPEI, entitled Start at the Bottom, Moisture Control and Surface Prep for Wood Flooring Installation. My name is Sharon Schaller. I'm the Member Engagement Manager at NWFA, and I will serve as your moderator for today's webinar. Now, before we get started, I always like to go over a few items so everybody's participating in the correct way. You should see the control panel on your screen in the upper right corner. You are listening in using your computer's speaker system by default, and therefore the computer audio button is selected. If you would prefer to join over the phone, just select phone call in the audio pane, and then the dial-in information will be displayed. Now be sure to enter your PIN number so you can hear the presentation, and then I will be able to mute you. You will have the opportunity to submit text questions to today's presenter by typing your questions into the chat box of your control panel. You may send in your questions at any time during this presentation. I will collect them and we will address them during the Q&A session, which is the last 15 minutes or so at the end of MAPEI's presentation. And then again, throughout the presentation, we will ask some poll questions to get your feedback and to make sure you're paying attention. Our first question is, what is your NWFA member business type? So if you would do your quick vote, and I will close it out in just a few seconds here. Are you a contractor, inspector, distributor, manufacturer, or retailer? If you can't find it, pick something close. Awesome. See that about 80% of you have voted. So I will close it out and share that with you. Looks like 29% are contractors, 45% inspectors, so a lot of inspectors out there, followed by 16% manufacturers, 5% retailers, and 4% distributors. So thank you for participating in that poll. So, and now I would like to introduce our presenter for today's webinar. Sam Biondo directs the MAPEI Technical Institute's 3 U.S. branches, which provide training for contractors, distributors, and the A&D community. Sam has over 25 years of international experience in the flooring industry, encompassing all aspects of flooring installations. A popular speaker at many industry functions, Sam's experience helps his audience easily comprehend new and innovative technologies. So Sam, in just a second here, I will make you into the presenter and give you control. And hold on, it just takes just a couple seconds to do that. There you go. If you would just accept that, you are ready to go. So take it away, Sam.
All right, from the beginning. All right, start at the bottom, moisture control, surface preparation. Everyone can hear me okay? And let's make sure I have control. I do. So thank you. So a couple things. First off, as everyone knows, this is an awful lot of technology for me. So some people that know me are pretty impressed right now. I'm a little impressed with myself that I got to this point. This is not normally the way I do presentations, but this will be interesting, and I'm looking forward to it. I appreciate the Vine to reach out to everybody and discuss these issues. I think these are some of the single most important issues in our business, especially nowadays with the cost of floors and going back and a lot of these all-in-one adhesives. All of this counts and works off of the premise that the surface is prepared properly. It's flat, it's level, it doesn't have an excessive amount of moisture coming through it. So we'll go through the steps as we go. I want to thank everybody before I get started for taking their time. I know how valuable time is. It's one thing you cannot get back, and thank you for sharing it with me. And on that note, let's go. So first things first, what are we going to learn here today? We're going to learn and understand moisture alkalinity and the effects that it has on concrete slabs. The next thing that we're going to talk about is the impact of vapor emissions, why vapor emissions causes floor failures, how moisture and mold can impact the health of a building. More and more you're seeing in our business and all businesses in the flooring side is there's a lot of concern about eco-friendly and green buildings and the long-term health and sustainability of that building and the floors that are being put in. We're also going to define what dry versus cured concrete is. I think a big problem that we have is a lot of us know how to work with the products, but we don't really understand what we're going over top of. So I'm going to get into a little bit of depth about explaining how concrete acts and performs and why things happen, and then what those products are doing to counteract it, to make a surface that's suitable for us to bond and install on top of. We're going to talk about RH testing and calcium chloride testing. What are some of the pros? What are some of the cons? And do we even need to do them? And lastly, how to specify indoor air quality in successful flooring installations. I think going forward, especially on commercial jobs, going forward, you're going to need to understand, you know, what the scenario is that you're going. If it's a brand new job, is it a remodel? Is it occupied? Is it unoccupied? And then that's going to help you make decisions on what products to select and what methods to select to go ahead and get the job done. First things first about water. It comes in three forms: a liquid, a solid, and a gas. In a liquid form, it's the water in the bottom of your glass. In a solid, it's the ice inside of that water in your glass. But when it gets to a gas, this is now like an invisible vapor that's rising up in through the air. This is very important to understand that. The other thing that you need to understand is, for the most part, it's in a constant state of cycling itself around. And very little water actually leaves the planet. It moves, but it doesn't really leave the planet. There are some scenarios where that can happen and do happen in very minute amounts. I'm not going to get all scientific-y on you and explain that. So I promise you. So, for instance, water in the evaporation process turns liquid water into a gas that's called water vapor. If the heat is taken away from the water vapor, it condenses. The condensation turns water vapor into a liquid. If you take the heat away from the liquid, it freezes and it becomes ice. It's one big cycle that keeps going up and falling down and going up and falling down. Right now, a lot of people up north are experiencing the third process where it freezes to become ice. Here in South Florida, where I'm located at, we just had our first cold front of the year. We're very excited, but we're not going to see water freeze to become ice. That's not the environment that we live in. So understanding what's going on with water and why it's constantly moving. It's rising in the form of a gas, it's falling in the form of a liquid, and in a form of ice or snow in certain instances. And it's just cycling and doing this over and over and over again. Moisture in a liquid state can create a lot of problems. First things first is understanding the concrete structure that we're on top of here. It has pores, or these little tunnels is what I like to explain them as. And in these little tunnels, this is how vapor passes up and through the slab and up and through there to get up to the surface or the bond line. What can make that happen is capillary action, hydrostatic pressure. All of these things will move vapor or water through the system one way or another. Before I get too far into this, I want to say something. One of the pet peeves of mine is I hear all the time people tell me that wood and water don't mix. That's not necessarily true. It's the unexpected loss or gain of water and wood that don't mix. For instance, Christopher Columbus sailed over here on a boat that was made out of wood. He was prepared, the wood was prepared to receive the water and be exposed to the water. A lot of people's decks outside are wood decks. They're built to anticipate rain and snow and different things like that. It's just that sudden gain or that sudden loss of water unexpectedly that goes ahead and starts creating a problem. So building your system for a high moisture environment, it can be done. A great example of that was I thought it was a really good idea when I was a young man to build basketball courts. That is, by the way, a young man's business, in case anyone was wondering. But I did a basketball court in the middle of Florida, in Clewiston, Florida, as a matter of fact, and they didn't have air conditioning in the gymnasium. And the system was designed to slide along a track. And basically, the floor was built in mind knowing that the wood was going to expand and contract. And I mean, I did this 25 years ago, which isn't fairly recent, but there are systems in place. As long as you can build the system in place to understand the loss and the gain of water, you're going to be fine. And the reason I bring that up is the capillary action that happens where it wicks water into concrete and pulls it through. This can become a problem. That's unexpected water. Hydrostatic pressures, unexpected water. All of those things are unexpected, and we have to address those. Let's give some other definitions here. One of the things, do I really need to address moisture in a concrete slab? All right, so as a manufacturer, I have an answer for you, and the answer is only if you want a warranty. If you don't want a warranty, go ahead, you can do it any way you want to do it. But the reality is, you have an obligation, A, to your customer, B, to yourself and to your reputation, and to the business and the industry to do this the right way. Why wouldn't we want to do this the right way? I have two sons, and I taught both of my sons this, one of the key lessons in life, and that's the difference between fault and responsibility. I use this example. If the dog jumps the fence and bites the neighbor, it's not my fault, but it's my responsibility. If I open up the gate and tell the dog to go and bite the neighbor, it's my fault and my responsibility. If you show up on a job as the installer and you don't go ahead and do the testing on the slab, or you just go ahead in spite of knowing that there could be a problem on a slab, and you start adhering product to a concrete slab that has a moisture issue, it is your fault and your responsibility. It's your responsibility to point it out and bring it to the attention of the building owners or whomever is responsible for it. So you can go ahead and have this addressed. Either you can address it or you can bring in an outside vendor. But if you don't do that, you are going to assume the fault and the responsibility. And I don't know how many of those you can have before your business starts suffering from it. It's really important. It's our job as the professionals to point this out. No contractors don't want to hear this. And yes, homeowners think this is flooring voodoo when you start talking about calcium chloride tests and RH probe tests and all these different things. They think you're trying to pull a fast one over on them. It's our job to explain it to them in the simplest terms possible, or have somebody else explain it to them in the simplest terms possible, that we have to do these tests, and here are the test results. Here's what we have to do going forward. And Sam's policy number 4, I never lost money on a job I didn't do. Sometimes you got to get up and walk away from jobs if they will not allow you to go ahead and prep the slab properly and prepare the slab properly so we can receive a wood floor on top of it. Moisture in a vapor state. This is a great example of this is get a glass of water, put ice in it, take it into the bathroom, close the door, turn the shower on hot, and watch it fill up with steam. The steam is the vapor, the water in your glass is the liquid, the ice is the solid. You have all 3 phases. That vapor is trying to find a way out. It's always looking. It's searching around the bathroom. You watch it. It's moving. It's looking for a way out. It's trying to relieve the pressure. And once it decides it cannot find a way out, it just kind of settles in there. That's the thing about moisture in a vapor state. There's a couple of ways of checking that. Again, we can do calcium chloride tests. We can do probe tests. I'm not going to get too deep into those. I think everyone has had enough information, has enough information about those. If we don't, shame on you. Contact the appropriate people, and you can get all the information you want about doing the test. I will suggest this, having read the actual instructions for the test after about 10 years of doing them, that I was doing them wrong for a while. So make sure you understand all the proper ways that you're supposed to be doing those tests. Vapor emission scenarios. Concrete dry-in issues, and this is now where, is it a closed slab or an above grade situation, or is it an open slab? And you're like, what? How am I supposed to know that? Well, you got to do a little detective work. I would suggest that we all become a little bit better detectives, and you've got to understand, is this a brand new building? Is this a hospital? Is this, just an office? Is it an existing building? People always say, well, I put down, the building's 20 years old, but it has a vapor barrier. Well, what kind of vapor barrier does it have? So, well, it has a 6 mil polyethylene. How long is 6 mil polyethylene supposed to last underneath the concrete slab? And how good of a job do they do when they put that in? You ever watch those guys sometimes? They're poking holes in it to let water release from the concrete pour. I don't trust polyethylene vapor barriers all that much anymore. And it's up to us, again, to pay attention and do the tests on the job to make sure that we don't have a problem or a moisture problem. In a closed slab situation, what I mean by that is this. A closed slab system is where the concrete slab is isolated. A permanent vapor barrier or an elevated metal deck is in direct contact with the slab are prime examples of a closed system. So it is hermetically sealed, or it is sealed at the bottom. That way, no moisture can rise up from below that and enter into the concrete structure. All the extra moisture in there is free water originating from within the concrete itself. This is good because at least there could be an end to this thing. Like whatever water it currently has, it's rising up. It's trying to evacuate itself out of there and get at and remove itself from the system. And at some point, enough of it will be removed that it becomes an acceptable slab or substrate to go ahead and bond to. When you go to an open slab, that's completely different. That's no vapor barrier or shoddy vapor barrier. And in other words, moisture that's transmitting from below the concrete and below since there's no vapor barrier, below that in the soil and the rock or whatever, that vapor is it's totally unchecked and ungauged. And it'll just come through at its own free will. You'll have no chance of controlling this, so you can go ahead and make that surface suitable to bond to. To me, anytime something like this comes up, this is almost a no-brainer. You're going to have to do some sort of moisture control system on top of something like this. And a lot of times, like I looked at houses as I started working out into the field, and just based on the age of the house, I just would go ahead and say, we're putting down a moisture control system. That's going to be part of it. And otherwise, I'm not going to do the job because I can't afford to get the callbacks. I can't afford to be down there. My reputation can't afford to take that hit. And it's not fair to the customer. One of the things, customers spend a lot of time and money on putting in floor systems, and this is a big thing for them. And then for you to go ahead and not do the proper preparation on the slab, it's not really fair to them, and it creates a lot of heartache and a lot of anger. Next thing, industry changes. Well, what has happened with concrete and cements? Well, now there's blended cements, there's curing methods, there's highly burnished concrete, there's lightweight concrete, there's fast track construction. And I kind of chuckled at that fast track construction thing because in all of my years of installing, I don't think I've ever was told to take my time and do slow track construction. All construction is fast track. Everybody's always pushing. Unfortunately for us, we happen to be at the back end of the job site. So a lot of shortcuts have been taken in front of us, and now it's up to us to diagnose whether we can work with them or we can't. How moisture vapor emissions passes through an interior slab. It's pretty simple. Moisture moves from lower temperature and higher humidity to higher temperature and lower humidity. I have two letters for you, AC, air conditioning or heating. Any type, that's why it's imperative that those units be on when you do the test, or those are going to be the conditions that the building is going to be occupied, lived, and performed in. So a moisture test moves from a lower temperature to a higher humidity. I turn the air conditioner on in my house, the temperature outside is a temperature inside of my house is 74 degrees with 50% relative humidity. I live in Florida. That's a nice, cool environment. Whereas underneath the slab, it's cooler, but there's a higher RH. That pressure is going to drive that vapor right up through the slab. I want you to think about it in the form of an invisible steam. I'm not talking about water that's defying gravity. I'm talking about a steam that's rising up through the pores, passageways, and tunnels that's built into that slab due to air and due to the hydration process. There's these little tunnels that are in there, and that vapor is rising up. When it gets and comes up to makes contact with the bond line of where your adhesive and your floor is at, all of a sudden the temperature changes. And when that happens, when you remove the heat from the vapor, it converts back to a liquid. And a lot of times you'll pull back sheet goods and you go, look, we got a problem, we got moisture in the slab. You have vapor in the slab that converted itself to a water by the time that you pulled it back because it had a chance to cool down. Moisture vapor emissions transports soluble minerals which condense at the surface. This is something we really kind of buzz over and don't talk about enough, but this is very, very important. Neutral pH is 7.2. 7 to 8 is neutral pH, and that's where all adhesives and most things want to perform at, is in that range. They'll go up to 10, 9, but 8 is really where everything likes to work at. Moisture vapor emissions migrates through the slab, and in the process, it pulls up a lot of these different soluble salts and different things like that. Moisture vapor condenses to a liquid and reduces the adhesion of the flooring system. Liquid has high alkalinity. That high alkalinity was in the pores. It can be as much as a 13 or a 14. I wanted to double check and make sure I understood this, so I added, I added these next two slides in here. Where does high pH come from? Well, it comes from calcium hydrate. And listen, I want to say this right now. I am not a scientist, but I did sleep at a Holiday Inn Express last night. But I'm not a scientist, and I don't pretend to be. I am learning these big words, and what's happening is like you're learning them. But I do know things happen. I've seen failures. Potassium hydrate, sodium hydroxide, all of these. Look at the pH levels on this. pH 14, pH 13, pH 12.5. Here's something I need you to understand and remember. The pH scale is a logarithm, okay? So at 7, we're at 1. When I go to 8, 8 is 10 times more acidic than a 1. 9 is 100 times. A 10 is 1,000 times. You need to think about that. If I'm at a 7, 8, a 9, and I go up to a 12 or a 13, the difference between 7 and 13 is 1,000,000 times more. 1,000,000 times more of anything isn't good. That is not good. That's going to attack the adhesive. It's going to attack the organics in the adhesives. It's going to break things down. Things are not going to work the way they were supposed to work. We really, really, really need to understand this. How are you changing the pH on the slab? By that moisture rising up. How do we fix this? We stop that moisture from rising up. What is a dry concrete anyways? Isn't concrete dry in 28 days? No, concrete is cured in 28 days, which means that all the processes of the cement, particles and spikes growing together, all of that's the curing process. Now, all of that extra water that's inside of there starts the going away process. At least 1 month per inch thickness, generally more than doubles in the wintertime. Lightweight concrete mixed designs are rated 2 times longer than normal concrete. Structural members will generally not dry as expected in degrees in the time for flooring installations. In other words, you got a lightweight concrete slab, you almost have to double your cure times on there. If you have a regular concrete slab at 4 inches, you're probably looking at 4 months from the day they poured the slab. Now, that's not that difficult to deal with because we're on the back end. But if it's a remodel of something, like there's an existing building and it's a remodel, they're kind of pushing pretty hard. If it's a brand new building, by the time 4 months goes by, I mean, that's a lot to have happen, unless we're talking about tilt-up construction in commercial applications. Now, you've got a lot to be concerned about because A, in 4 months, they're screaming for you to show up at the job, and B, they went ahead and sprayed that concrete with some sort of form release because they poured the walls that are standing up right now pretty much on top of that concrete slab that was existing. That form release is blocking those pores and getting into those pores. Man, that stuff is going to have to come up. The quickest, surest way to test concrete to find out if it has any type of contaminants on the surface is just bring a bottle of water, pour some on the floor. If it penetrates down into the concrete slab, you're more than likely good to go. If it rolls around like it's on a piece of wax paper, you are not good to go. Then no bueno. And you're going to have to go through there and grind it off, sand it off, scrape it off, whatever. I start easy with a buffer and I work my way up the ladder and get a little more dramatic until I can get water to penetrate into the slab. Vapor transmissions, not always on grade. Lightweight concrete floors, they have expanded clay or shale inside of them, and they're expanding and contracting. Larger structural members, components, greater mass. The bigger the building, the more moisture that's in that building, and then as it's trapped and there's floors up above, that moisture just doesn't leave the building. It just kind of gets drawn into the next floors. Both have more moisture, high MBRs and RHs. You need to plan your budget, or you need to work with the general contractor if this is a commercial job, to make sure that the moisture mitigation systems is part of the deal. The last company I worked for, which was a custom wood floor company, the gentleman tells me now that for every 500 feet, he bids in a certain amount of bags of leveler and pretty much assumes that it's going to be a moisture issue on the job and bids it into the job just so he doesn't have the conversation with the homeowner. These are the moisture tests. Again, I'm not going to get into how, what, when, and why. You can pick the one that you like. I will tell you, you need to read these instructions, though, and find out where these tests need to be located into the building. That's where I was making my mistake, is I was putting them too close to windows, too close to saw cuts on the floor, too close to doors. So make sure you understand the exact where these layouts need to be. How do we fix this? We fix this with film forming membranes. Film forming membranes can come in a couple of different ways. They can be a 2-component epoxy resin, or they can be a water-based 100% solids. They can be a single coat or multiple coat. They can be sand broadcast. There can be no sand broadcast. There's all kinds of different ways. A couple of things I want to explain right now is there's lots of really good manufacturers out there that make really good products, but they don't work properly if you don't read the instructions. I know as men that we don't like to read instructions. I know we think we know. And just because you've read someone else's instructions doesn't mean that those apply to what you're currently doing. Read the instructions. Find out what the manufacturer wants you to do. There's a reason that manufacturer is asking you to do it this way. They're the ones who design the product and know how it works. Make sure you understand what the applications are and what the limitations are for the products that you're looking at. You know, there's 2-component epoxy resins, for instance. You know, for floors that are, for no-brainers, this is perfect. You go in there, you shot blast, you put it down. But I got to tell you, about 80% of the floors that I checked weren't at the 20 to 24% moisture range. They weren't at these high numbers. They were, you know, they were an 8. On a calcium chloride test, they were an 8 or a 9. I needed something not that robust. Now there's lots of options out there. Make sure you understand the limitations of the products. That's probably the best advice I can give you here. Film forming membranes, the advantages, has the ability to be applied both fresh and old concrete. So I can have older concrete, or like I said, it can be a remodel. A lot of people in South Florida have porches that have, you know, the roof line continues down their back porch, but it's exposed and those slabs are pitched. I'm not so sure there's a vapor barrier underneath that concrete on my outside back porch. Now other people, the next people buy the house, they go ahead and they want to go and close in that back porch. As soon as they do that, and as soon as they turn the air conditioner on in that room, that moisture is going to come wicking up through that slab. That has to be addressed. So that's an old concrete that I can go ahead and apply to. Or I just go ahead and add a room addition onto my house, which is fresh concrete. I'm going over top. It can withstand a constant pH of 14, which is very, very high. Provides proper surface pH for floor applications, which brings it down to a 7 or an 8. That's nirvana when it comes to adhesives and products. Capable of tolerating high and unknown MBRs. Possesses a perm rating of less than 0.1 per ASTM E96. It also should meet the ASTM F3010-13. I have a confession, I had to look that up, which is the standard practice for two-component resin-based membrane-formed moisture mitigation systems for use under resilient floor covering. That's a lot. So these are great. These are absolutely amazing, systems. However, they're not for everybody. And a lot of times I'll get building or I'll get company owners going, well, why don't you come out and you can show me and my sales guys how to do this? No, I don't want to show you how to do this. I want to show the person who's going to install the product how to do this. That's what's important. Is the person who has to do it needs to understand how to do this and what to look for. Proper surface preparation for form-filling membranes. So acid etching is okay? No, no, no. And in case I didn't say it clearly enough, no, absolutely not. It is not okay. We're going to add more acid residue to the floor because it already has an acid residue on it? This makes no sense to me at all. That acid that you use to etch that floor is going to go down into those pores, kind of open them up and coat the inside of those pores with acid. And the first time moisture rises up to the top, who knows what the number is going to be? No, no acid etching. Please stop this. I don't care how long you've been doing this. I don't care if you got an uncle that did this or if the old guy showed you this. No acid etching. Proper surface preparation. It can get very, very industrial. Mrs. Smith, of course, is not going to let you crank up a 220 shot blaster inside of her house and do that. Maybe she will. That would be kind of exciting. But on commercial jobs, I will tell you, this is a really good way. It opens up the pores on the surface. It gets rid of the contaminants on the surface and gives me a texture. One of the things we don't really understand enough in our business is the shortest distance between 2 points. That's right. I heard one of you say it. I could psychically pick it up. Is the shortest distance between 2 points is a straight line. That also includes in a plane on a floor. So when I have a texture, I actually have more surface area than what I did as the crow flies in a straight line. A 12 inch by 12 inch area that has a shot blast might have an extra half an inch of surface area by adding texture to it. A great way to do that is take 2 pieces of paper, crumple one of the pieces of paper up, unfold it, and now lay it back on top of the piece of paper. One piece of paper, as the crow flies, is actually bigger than the other piece of paper. The one that's crumpled up actually has the same amount of surface area. So point being is sometimes adding texture will increase your bond strengths.
Sam, before we go on to this one, let's get a little break and get some feedback. Yeah. I'm going to just jump right to your second question that you had.
Thank you, because I blew right by the first one.
You were just so excited. I didn't want to interrupt you. What moisture control system do you use? So please cast your vote. Is it 2-part, single component, 100% moisture curing urethane, or hybrid polymer-based wood flooring adhesive? Or don't use? Looks like I'll just leave it open for a few more seconds. The majority of you have voted. Okay, I'm going to close that out and share those results with you. And Sam, looks like the majority is the 100% moisture curing urethane or hybrid poly-based adhesive. That's 39%. Followed by single component is 27%. Don't use 22%. 2-part is 12%, if that gives you some good information. So thank you all
Yeah.
voting.
No, thank you very much. And that's important. And that brings me up to the next point. These are ICRI concrete surface profiles. Basically, the surface profile that we're looking at is basically what your sidewalk looks like. A little bit of texture inside of there. That's going to help and increase your bond strengths. Surface prep contaminants, you want to make sure, again, the quickest way to find out all right, I don't have a moisture issue on this job. I've checked it, I don't have it. Next thing is, am I going to be able to direct bond to this slab? And how do I go ahead and do that? Well, I'm telling you, pour some water on the floor and see if it penetrates. If it winds up rolling around like it's on a piece of wax paper, you're not going to have good bond strength here, man. You know what you're going to do for me? You're going to make samples, and we greatly appreciate samples. But that's not good for you or your business or the customer. So make sure that you go ahead and you watch that water droplet break down and penetrate into the slab. What can cause some of these problems? Well, look, general slab conditions, man. There's all kinds of things. There's a thing called crazing. I thought that's what my wife thought I was. But crazing is minor surface shrinkage, basically due to low humidity and high winds. That sounds an awful lot like Las Vegas to me. Overuse of placing tools and premature finishing. So it's all cracked up. It looks like alligator skin is what it looks like on the surface. You can't direct bond to that. You're going to have to go ahead and remove that. Blistering, surface finished too early. They got on it too early. You trapped the air and the water inside of there and brought all the cream up to the top, and it wouldn't allow the air and the water to pass through it. Dry, windy conditions again. It basically, it dried the top of the cake before the middle of the cake. Overworked and air-entrained concrete. All of these things are not good. Scaling is caused by freeze-thaw damage when they're in entrained air where they use de-icing salts, can also be attributed to finishing techniques. And spalling, this is a little bit deeper now. Deeper surface defects than scaling can be caused when the mix is too wet, the cement paste rises to the surface, or more importantly, the rebar is corroding. When rebar corrodes, that's telling me that carbon dioxide is getting to the rebar through the cement structure of the system and creating it to corrode. There's corroding and rusting. And corroding, it's expanding on top of me there, and it blows off the top cover. You'll see this a lot when you drive over overpasses, and you'll see football-shaped, looks like little blowouts on the overpass, and then you see the rebar, and you think to yourself, wow, somebody hit that. A lot of times that is where the rebar is too close to the surface when they poured that, and it blows it off. It blows off the surface cover and exposes the rebar. These conditions have to be fixed. Discoloration's another thing you want to look for. They might have tried to dry the slab out with plastic on it or something. This is changing the pore structure on the surface of that concrete, and it could impede the way that you direct bond to it. And dusting is with finishing with bleed water. Dusting slabs, or they got wet after they poured. I live in South Florida. You wait 10 minutes, it could be raining. You cannot direct bond to a dusty slab. You're either going to have to go ahead and remove that or find some other method to go ahead and fix the surface of that. Surface prep materials and methods, what type of surface preparation is required? That's really up to you, your skill set, your likes, and the job site. And what does the finished floor manufacturer recommend? So understand, if you're gluing down a wood floor, a pre-made wood floor, pre-finished wood floor, you want to find out, what do they want me to do? How do they want me to fix this? All of this is going to help you ensure that you can maintain the warranty on that job. This next conversation is, the last time I was at an NWFA convention, someone asked me a question, and I got to be honest with you, I wasn't prepared to answer that question. Like all great questions that you're not prepared to answer, every day you drive home, you go over in your head how you would have answered the question better or differently. The question was, all manufacturers with these all-inclusive adhesives want 100% coverage. How do you obtain 100% coverage? Well, to that gentleman who asked me, I want to let you know I have an answer for you that's a lot better than the last one I gave you. So the answer is very simply, A, you have to have a flat floor. B, I have to have flat wood. And C, I have to use the proper size notch for the adhesive. That is the only way that I can ensure that I'm getting 100% coverage on the back of that wood. The next thing is follow the manufacturer's directions on how they want you to comb the ridges out and what they want you to do. But if you do not have a flat floor, if you have a whoopty in the floor, then there's no way that adhesive is going to make full coverage, full contact with the back of that piece of wood. And if there's a problem, you're giving them a way out. So how do you get flat floors? You get flat floors by going ahead and doing proper surface prep, pouring self-levelers, using mortar beds, or using patch, crack isolation membranes. There's all kinds of different ways. But A, flat floor, B, flat wood, and C, proper size notch trowel. You hear all the time that it's an industry standard. The American Society for Testing Materials and the American Concrete Institute, these are the industry standards. When you hear manufacturers say, well, industry standards say that you have to do it this way or you have to do it that way, it's not the company that's saying that. The ASTM, the ACI, and the ICRI, they are dictating to us what they want to see happen. And as a manufacturer, and other manufacturers all do, we build our products to go ahead and meet their needs in the way that they want to see these products applied and at the depths and the ranges that they want to see them applied. Surface preparation for self-leveling underlayments, you want to go ahead. Some of these require mechanical profiling. Some of them don't require mechanical profiling. Some of them are normal setting. Some of them are rapid setting. Some of them don't even require primer. Read the data sheets and understand, just because you're using one manufacturer's product and you go to a different product made by the same manufacturer, that you follow the same steps. You don't know that until you read the data sheets. Surface prep self-leveling underlayments is to be matched and underlayment requirements. There's low prep, there's no shot blasting, there's gypsum based, there is specialty fast track, there's quick setting. There are even products that you don't need the HVA system on. Do you understand that probably 95–98% of all your surface prep products require the HVA system to be in place and on when you put them in? But there are several of them now that don't require that. Some of them don't even require windows. They just require certain temperature ranges to be maintained during the install process and for several days after. So there are a lot of options out there. I get asked all the time, how come you guys have so many surface prep products? The answer is always the same. How come you have so many golf clubs in a bag? They all have a certain application. Understand what the application is. When do I use a patch or when do I use a screed? Well, you know what? It creates flat surfaces. It adds strength and rigidity to the concrete. And the last thing is ADA ramping. I told you earlier I used to build basketball courts, and some of the most animated conversations in contractors' trailers was all about who was going to be responsible for the elevation difference between the basketball court and the vinyl, the VCT floor in the hallway. And then you had to follow handicap code to go ahead if you did any ramping. So understanding ADA ramping and how and when and where, screed materials are a great way of doing that. By the way, self-leveler doesn't do good in ramping. It self-levels, so it doesn't do good in ramping. Most self-levelers require primer. Check with manufacturer's recommendations on the primer, on the size of the notch roller. Do they want you to trowel it on, broom it on, squirt it on? They don't. They all have, there's all kinds of different methods. And do yourself a favor. Don't use one manufacturer's primer and another manufacturer's leveler. That might work great until you have a problem. And then when we show up and we look, man, you're going to stand there and be stuck holding the bag. Self-leveling is the surest way to achieve a flat underlayment, that is to receive a finished floor. Most glue manufacturers require 100% glue coverage on the back of wood floors, and self-leveling is a crucial step to help achieve that. I can't explain that enough about the flatter the floor, the easier your job gets. In South Florida, we have a lot of terrazzo floors, old terrazzo floors. I refuse to go over a good-looking one, but a lot of them were beat up and not so good looking, and they were the easiest jobs to install because they were ground flat, and you used less material. You didn't fight the floor. There was no fighting glue. There was no patching with glue. There was no humps to worry about. They were a piece of cake to go ahead and install directly on top of. Get that floor flat. And one more last time, I'm going to say it out loud. Follow manufacturer's instructions. No, these are not opinions. There's a very good reason that the people who manufacture and make the product want you to apply it in a certain manner. Follow the instructions, guys. So many times, so many claims are self-inflicted wounds. Please, just read the instructions. Do it right. In summary, assume a concrete slab may still have a high moisture content. Assume the substrate is not flat and level. Know your moisture limitations for the flooring being installed. Test to understand the conditions of the concrete. Substrate preparation is essential. Read the directions for all products. Any questions?
Well, thank you. Thank you very much, Sam. Okay, so we're now going to begin answering the questions submitted during today's presentation. So as a reminder, you can still submit those questions in the chat box in your attendee control panel. So Sam will be answering all your questions. So type them in. We don't have very many there, so I'm sure there's a lot about moisture that you have questions on. But I do have our first question. Sam, comes from Brian. And he says, so slabs in units in a high-rise condo building are closed slabs?
Great question. The answer is probably the last 30 years, the answer is yes. Some older condominium slabs, they used to go ahead and put forms, wood forms, and support them and pour on top of them and then break the wood forms down. But you see them now. You see it looks like a corrugated metal that they put on there, and those can be closed slabs. But don't always assume. There's a great way of telling. In high-rise buildings, like if they have a drop ceiling, pop one of the tiles up and take a look. And the reason I tell you that is don't assume because you're on the third floor that you're not going to have a moisture issue. That vapor is rising up. And if I have an open slab up above me, that vapor is going to rise up and come in contact with that open slab. And it's going to penetrate that slab, and it's going to keep rising up until it escapes the building somehow. Whereas if I have a closed slab, then the air conditioner can help wick a lot of that out of there, and it won't penetrate through the bottom. So make sure, figure out a way to test. Again, be a good detective and snoop around a little bit on these, especially on high-rise buildings.
Well, thank you. So our next question comes from Eric. Why with concrete we want to block moisture, but with a substrate such as plywood or gypsum, we want to retard?
Well, that's a great question. So I want to slow moisture down with gypsum. With plywood, I want to let it pass through. You could let it pass through in concrete, but the problem is how long is it going to take and how much is in there? If it's closed, if it's an open slab, it could be wicking moisture forever. And maybe you don't want to block it. Maybe the answer is you can't direct bond to it. I've done a lot of systems sleeper systems where we just went ahead and put basketball courts are on sleeper systems where we go ahead and put 6 mil polyethylene on the floor, and then we put the sleepers on top. We run the polyethylene up the wall. We seal the seams of the polyethylene in the middle of the basketball court, and then we have a gap in between there. And in essence, that vapor is rising up, hitting the back of the polyethylene and wicking out the sides of that slab, so it's not attacking the back of the floor. So sometimes you opt to not direct bond to a concrete slab, but if you're going to direct bond to a concrete slab, you want to control that moisture. Now, if it's at 24, you're going to block it. If it's at 6 or in a 5, if it's not that extreme, then it could be a matter of control. And again, certain products have certain limitations where they let some of it leak out or wick out slowly. You're just controlling it. So understand the numbers that you start with will help you determine what products that you use later on.
Eric has a second part to his question. And can't concrete become too brittle as with plywood?
Well, here's what I know about concrete. They use them for bridges. They use them for structures underwater. When concrete cures, when the cement particles form and interlock and interlace together, then at that point, it doesn't really get that brittle. Where it gets brittle, like especially up north, like your driveways, is water gets inside the pores, and it's a freeze-thaw scenario where water, when it freezes, it expands 9% its original size. A great example of that is an ice cube tray. You fill it up with water evenly with the top of the ice cube tray. You put it in the freezer. You pull it out the next day, and the ice cubes have humps on top of them. So as that water's expanding, that's inside the concrete slab, it's busting it up and pushing it apart. And I think a lot of times that's where people think about concrete getting brittle. But for the most part, it doesn't really get that brittle, or it stays the same. And actually, through the course of time, it actually gets stronger and builds strength. On giant concrete slabs, the slab isn't expanding. It's condensing in on itself and pulling in on itself. A great example, go to a slab that's 28 days old. You can take a cut nail and drive it in with your hand. Go to a slab that's 28 years old, and you have to drill a hole to put the cut nail in. Go to a slab that's 50, 60, 70 years old. You burn your bit up trying to drill the hole to put the cut nail in because the concrete's pulling in on itself and getting tighter and tighter and stronger and stronger.
Thank you for that. Claudia has some comments and a question here. It would be nice if someone could demonstrate and prove 100% coverage through microscopic and laboratory examination, as I question if 100% can be truly achieved 100% of the time.
Yeah, no, I kind of agree with her.
Yeah, if the slab meets all manufacturing specification, as visible examination might appear 100%, but technically could be 98.55 or less. Any suggestions as we are confronted with this as far as post-installation and only visible examination of the adhesive transfer at time the plank is removed?
That is a great question. The answer is you've got to do everything that you can do. You've got to make sure, again, even if the slab meets the industry standard, maybe it needs to be a little bit flatter. The main thing is if you have whoopties in the slab, if you have a void or something like that, you're not going to make that contact. You got to understand how a all-encompassing moisture barrier works, whereas it's adhesive, a sound deadening membrane, and a waterproof membrane. How all that works is the ridges get knocked down and it fills in any voids that are left by the trowel. If I'm not making that 100% contact on top of there, then I'm not filling in the voids. And if I have a void, I'm not vapor proofed. And this is why one of the trends, I will let you guys know, and I was surprised to see how many of you actually went with those glue systems. One of the trends right now in our business is people are going back to a two-part system where they have a vapor proofing system that they put down first, and then they come back on top of it and trowel with just a normal wood trowel on top of that, because you can visually inspect your vapor proofing system.
Okay.
Go ahead.
I'm sorry. She's got another question here. What about vented metal decks? Those are open, correct?
Yeah, they're partially open. So this is a great example of a thing called diffusion. So diffusion is this. In the open areas, that deck is going to have the moisture is going to be dried out. More so in the open area than where it's not vented and where it's closed off. And what happens then is a capillary action starts to happen because that moisture that's in the other area where it's not as dry wants to go to the dry area to help equalize out the slab. And so that moisture is trying to move over and get inside of there. And this can create havoc with, you know, based on when you're doing a calcium chloride test, or you're doing a probe test. If you do that probe test by accident over a vented area, you will get a slightly different reading than you would if you were a foot and a half over to the left or the right of there. And you know, it's understanding. If it's a vented, I would treat that as an open system.
Okay. Timothy has a question. When using a moisture barrier or all-in-one adhesive, is it important maybe to make sure that your patch material can handle the high moisture that your barrier or adhesive is blocking?
Wow, Timothy, you set me up with a big softball. Thank you, Timothy. He doesn't even work for us either. Absolutely. Not all patches, not all self-levelers, not all skim coats are qualified to have that moisture trapped between the barrier and the concrete substrate. You want to make, I know all manufacturers that I know of, they all make something now that is what I like to call an interior exterior grade self-leveler, patch, and skim coat. And you want to definitely use those in those scenarios that can handle that high degree of moisture. And they've been tested. These are not just souped up regular patches and skim coats. These are a different category of product, and they've been tested.
Okay. Johannes has maybe a comment here. Maybe you can comment on it. Plywood subfloors rot potentially if you block the moisture, but it is a dilemma over crawl spaces with excess moisture.
You are correct. They do. And I don't ever want to recommend you blocking, you know, over top of plywood. What the heck is the sense? I mean, if my finished floor fails or my plywood subfloor fails, I have a failure either way. I don't want to do that. And I want to be careful about messing with structural. I mean, honestly, I hate to say this out loud, but if I have to sacrifice anything in that system, the structural, the substrate, or my finished wood floor, I want to sacrifice the finished wood floor in that system. I don't want to start trapping moisture on the structural aspects of that house or that building and having that start to fail. The picture that's on the question is one of the last commercial jobs I did, and the only reason I had to redo that job was that the substrate failed and not the finished floor. That floor happens to be sitting on a 1.5 million gallon cistern that's been in there since 1920, and that vapor passed through the concrete cistern and attacked the subfloor, and that's what failed. The wood started falling through. So you're right. You don't, on plywood subfloors, you don't want to go ahead and trap that.
Okay. Brian has another question. There are many adhesive products out there now that say you can use them without moisture testing. What's your input on that?
Well, they do say that, and my input on that is you better follow those directions to the T. A lot of them want you to use a certain trowel at a certain angle. You comb it in a certain direction. Here's the other thing too. I want to say this, and I felt like I shouldn't have to say this out loud, but I'm going to anyways. Traditionally, at the end of the day, when I'm gluing down a wood floor on a concrete slab, I am measuring my rows of wood that I'm trying to work off of the floor. And so I will measure 2 feet, 2 feet 1 inch, and snap a line, and I'll spread glue in there, and the wood will cover up to 2 feet, leaving me a 1 inch line of untouched glue. So when I go to start the next row and I go to trowel, I don't have to go ahead and bump the back of my trowel up against that finished board. But at the end of the day, I usually leave it short so I don't have glue boogering up underneath the tongue. So the next day when I go to start, I'm not fighting to get the floor started. I can't do that if I'm using the moisture barrier adhesive method. I have to go ahead and leave it short by about 1/4 of an inch and take the flat side of the trowel and flatten it so it comes out past where the end of the board's going to be, So when I start in the morning, I have a monolithic layer at least already down underneath. And so many times I look at claims on floor systems that are moisture resistant, sound resistant, all of that. And every 300 feet in a straight row, the floor is buckling. And I go, you stopped here, you stopped here, you stopped here, and you stopped here. And the guy looks at me and goes, how do you know that? And I'm like, because you don't have, when you pull the boards up, there'd be a little 1/4-inch strip of no product underneath there at all. You're trapping that moisture underneath there, and you're giving it only one way out. And it's going to go ahead and force its way up and out of that little void. So you've got to figure out a way to carry it out past the end of your day board. So when you start in the morning, you're not fighting it. Does that make sense? I hope so.
Okay. Joseph has a question. What is the correct amount of time that should you wait to put plastic over self-leveling for a clip and lock floor?
Ooh. So I would treat that floor, that self-leveler, like it was an impervious sheet goods. So you look at certain manufacturers, usually rapid setting self-levelers have a 24-hour window. Normal setting, regular cement, normal setting self-levelers have a 72-hour window before you can go ahead and put an impervious surface on top of it. I would treat that like an impervious surface is how I would treat that. And some of them, there are some self-levelers that are like super, super rapid, literally 3 hours, you can go ahead and do that. Again, you get what you pay for, and you need to understand the parameters and why there are so many. Once you get into this, you'll start to understand why there are so many different products in the same category, because they all have slightly different applications.
Okay, another question from Eric. Can we trust an engineered pre-finished 3/4-inch material that it may withstand up to 80 to 85% RH? Just sounds obviously high.
Yeah, I agree with them. Well, I guess, again, we're back to that unexpected show up or loss or gain of moisture. I guess if the AC's on or the building's climatized and it's acclimated to the building and there are no sudden changes and everything stays the same, I've leaned towards, if I went back into installing for a living again, every wood floor that I put in over a concrete slab, regardless of what I got for a reading, I would go ahead and put a moisture control system in place.
Okay. Julianne has a question. If the concrete accepts the water test and disappears into the concrete, then can we assume the concrete is ready to accept adhesive rather than profiling or grinding the concrete? Mm-hmm.
Okay, so again, another good question, and the answer is, yeah, you can assume that it's ready to receive adhesive, but what does the, what does the adhesive want? Some adhesives and some manufacturers want a profile no matter what. Some products are, you just do basically what we call a water drop test, and you drop that water. If it absorbs, you're good to go. That's good enough. So I can't. The answer seems to be the same. I could answer every question with the same answer. You need to read the instructions. It'll tell you everything you need to know. But I won't do that to you, I promise.
Okay, let's see what else is here. Joe has the fine print on some no moisture testing adhesive still will state an MVER or relative humidity limit.
Yeah. Gosh, I'm going to get in trouble with my bosses. I'm going to tell you a little secret. Read the first page, but really read the second page. So, yeah, I mean, a lot of times the answer is they will have a limit. That's a great opportunity to pick your cell phone up and call that 1-800 number and call them on it and go, guys, why am I looking at this? We tend not to, a lot of times they're oversights. A lot of times, this is a fluid business, no pun intended to the presentation. But a lot of times things are changing on the fly. And after a couple of years of a product being on the market, not having any complaints and not having any failures, you're starting to change the parameters of that product. And maybe it doesn't get put on the data sheet. So when in doubt, pick the phone up and call somebody on that 800 number that's on that data sheet and ask them, why am I seeing this? Why is it saying this? And that'll let you know if you're good to go or not.
Okay. All right. You've had some great comments here, great answers to the questions, Sam. Thank you so much. And thanks for everybody for attending today's webinar sponsored by MAPEI. If you have any other questions, here it is. Thank you, Sam, for putting that on the screen. There's his information. You can contact Sam at that email address if you have any further questions, because we've ran over just a little bit this time. But
I got long-winded? Nuh-uh.
And I didn't even do all the poll questions. So
right.
Once you leave today's webinar, you will receive a survey. So we're just going to ask you to please provide your feedback. And then you'll also, usually within 24 hours, you'll receive the link to view today's recorded webinar. So NWFA will continue to host free webinars in 2019. This is our last one for 2018. One's in 2019, so we ended with a bang, Sam, so thank you for that. They will be held always on the second Wednesday of each month from 2 to 3 Central Time. Regardless of what you guys get in your email, it's always 2 to 3 Central Time. It's never any different time. So occasionally, we will host an extra webinar on the 4th Wednesday of the month, and that's from 2 to 3 Central Time as well. So be sure to register for the next webinar on January 9th. That topic is yet to be determined. So each webinar is also worth 1 continuing certification unit for all of you guys that need credits for your certification maintenance. So on behalf of NWFA and MAPEI, thank you for joining us today. Have a great rest of your day and a very Merry Christmas, guys. Thank you.
Thank you.
Thank you, Sam. Did a really good job, Sam.
Thank you very much. That was
a lot of great comments here.